Good afternoon to our next webinar. Today we are going to talk about a high available storage cluster running as a virtual storage appliance under VMware. So we are going to configure our own hyper-converged high available infrastructure. And we will show how easy it is, and we will show the tricks which you need to know in order to build such an infrastructure. First, maybe we just talk a few words about OpenE JovianDSS. This is a ZFS based product, so plenty of the features which are coming with ZFS of course are built in, and we utilize them. We will not talk about all the details because for all the details there are different webinars. Today we focus on the hyper-converged infrastructure, so I will just introduce very quick. Of course we have active load balance high availability storage cluster in the Jovian built-in. So this is a built for the mission critical applications. There is no single point of failure. There is a maintenance possible while cluster is running, so there is no need to stop the services if you need to, let's say, replace a node or replace some hardware or update the software. All the maintenance stuff can be done while all services are available. So because we have here independent virtual IP addresses, so the cluster services of course can be stopped for a while, and you can make your changes, reconfiguration, hardware replacement, and you can start the cluster services again while in production. And there is also nice advanced management GUI. Everything what you do from one node, it is automatically synchronized to the second cluster node. Okay, so we have all these plenty nice enterprise features like tiered RAM and SSD caching, thin and over provisioning, inline data deduplication, inline of course online data compression, which is switched on by default even, very high data integrity features with self-healing, and extremely good scalability to few petabytes in one node. So regular production QA, our quality assurance is testing Jovian with 550 hard drives. So when you are connecting 8 terabyte drives, so this is just even 4 petabytes storage. So let us shortly talk about these enterprise features, but sorted by data integrity, data protection, data availability, data acceleration, data optimization, data accessibility, and data virtualization. So of course when you are going to sell storage appliance, this is a serious. It means the data integrity need to be addressed somehow. In our classical solution DSS v7, there are also plenty features which are giving you very high level data integrity level, but in this case we have something unique because the data integrity is directly on the user data, not on the, let's say, black blocks which are used in the RAID controller. And additionally, all data and metadata is due to checksumming. So everything what is written to the pool is written together with the checksum. So when you will read this data later on, that will be checked whether data is matching the checksum. If not, the so-called self-healing algorithm will working and then getting data from the mirrors or from the parity and providing user always proper data. Atomic transaction means everything what is written to the pool, it is valid, and it's not incomplete transaction because of atomic writes. So this is a write which you can compare to the writes to the database. So the pool is always consistent. So there is no way that after any catastrophic failure the pool will be inconsistent and you will need a repair. So there is no repair tool at all, because by design you are not able to corrupt the pool. Of course, if you will remove more disks than the redundancy level, then this is not a perpetuum mobile. You will kill your data. But in normal situation that all the redundancy, all the hardware is okay, and you have a power failure or some memory failure, some other failure, maybe last few seconds will be not treated as a valid transaction because it was not atomic write completed, but the rest will be always available. So here it is big advantage, because after catastrophic failure, when the system is able to boot, it is always at once ready to run. Data protection, so n-way mirrors, and the mirror is not only just a 2 disk in the mirror, and then you have plenty mirrors. You can have a 3 disk in the mirror, so you will have a much higher data redundancy due to disks, right? You can put 4 disks in the mirror. I have seen one was making lab work, and it was connecting even 24 disks in the mirror. So there is no limit for the number of disks in mirrors. We have seen that banks are always very often using 3-way mirrors. So of course, single, dual, and triple parity. Triple parity is something what is much better when you compare to the regular RAID controllers, as they offer only 2 disks for parity in RAID 6. So asynchronous data replication to collocation, doesn't matter whether it's iSCSI or NFS, we can move the data to the collocation. This function is still in the beta phase, so it is in the QA testing, and the next release will have it built in. We have it available on the FTP, the new version, so if any one of you would like to test it, you are welcome. Copy on write. That's the way how ZFS is working. Thanks of this way, we have a so-called very cheap, means there is no really big work to be done to create snapshots or clones. They can be created very easy, instantly, very quickly, and you can create, I will say, even million snapshots, and you will not have the performance degradation. VSS hardware provider, if you are talking about snapshot or clones, then if this is a regular virtual machine, if you take snapshot anytime, and when you clone it, and then when you run virtual machine from the clone, the virtual machine most probably will show that it was not properly shut down. You just confirm and the machine is starting. But when the virtual machine was running MS SQL or Exchange or some other databases, this is not the case, that the database will be mounted always. So actually opposite, mostly you will have a problem to mount a database, because the database is mostly not consistent on the disk. So here you need a trigger which is making the database consistent on the disk, and the snapshot is offloaded from the virtual machine to the storage, and the backup software is making backup from the snapshot from the storage. So this makes possible to makes backup let's say even every hour, or even often if you during production hours, during heavy duty load. Data availability, of course, here is a high available cluster. This is a dual controller model, means there are 2 controllers and the shared storage. This is really high availability solution, because you can start with you can work with single node, or you can even start your storage with a single node running everything via virtual IP, and later on you can add a second node while in production. Also, you can replace a node while in the production, or you can make some maintenance reconfiguration while in production. This disk redundancy is also connected to data availability, so everything is repeated here, but we were discussing this already. Data acceleration, that's a very big point, because we expect from the storage appliance very good performance. So there are plenty of solutions which unfortunately not as performant as we expect, or we have no option to tune it or make it better. Here there is a lot of possibilities to make it better. First, everything what is written to the pool is written to the memory first. So everything is always cached in memory. And because memory will be having problem while you have power failure, this need to be protected. So there is a so-called write lock concept, sometimes called ZIL, so ZFS intent lock, which is protecting data which is just cached in RAM. So everything what is cached in RAM will be also additionally locked to this separate lock device, which is very fast on random writes. So that will be mostly enterprise SSD disk, which is today up to 100 or even more 1000 IOPS on writing. The disk capacity can be very small, so you are buying just the smallest available capacity that will be today maybe 100 gigabyte. This, if you want to have a really enterprise level protection, you should mirror such a disks. Okay, but if you want the very high performance, you don't need to lock. In such case, you may switch the sync option in the volume or data set to disabled, and everything will be just cached in RAM and not protected. For the non-mission critical applications, like let's say video surveillance, when you are just saving data from the hundreds of cameras, in such case the most worst what will happen, the up to last 5 seconds of the video can be missing in case of disaster, and nothing else. So in such case, probably there will be no need to invest in very expensive SSD to protect such a write cache. Random I/O is written as a sequential transaction. So everything what is collected 5 seconds long into write cache then is formed as a transaction group and is moved in sequential way to the pool. So pool mostly is not really need to be extremely fast, especially in random, and everything will still behave like very good random performance. Of course, if you write more than the pool is able to get in the few sequential streams, then you may have a performance degradation. But here things like over 100,000 IOPS is just very easy to reach. Then on the reading side, reading side works a bit different than the writes, of course. On the reading side, we are using here RAM as a caching as well, but here much more RAM will be used for caching than on write side. And the RAM is the first level of the cache. If you need more in cache and RAM is not enough, then of course we add SSD, and this will be expanding read cache in RAM. So that's the second level cache. If the data is not in RAM, then will be checked if it's in the SSD read cache. If not, then unfortunately you have to go directly to the pool and read from the pool. But probably next time it will be already available in cache. Here there are two kind of algorithms like most recent and most frequent. So most recent data, if they go into the cache, and data which are frequently used are tagged also as a frequent data, they will be also trying to put into the cache. Resilver rebuild data only means when we are replacing the disk, when the disk is or pool is half used, let's 50% of the available capacity is on the pool, so the disk will be replacing only half of the capacity, because it is replacing data, rebuilding the data. That's why the new word called resilver, which is nothing else like rebuild, but the rebuild was somehow defined that it must rebuild all the blocks in the hard disk. To differentiate this, there is a different word, but meaning actually the same. Okay, compression and dedupe, of course, also here has an influence on the performance. In not every case, but in many cases, you will have performance improvement thanks of compression and the duplication. And data optimization is also compression and the duplication, especially if you will decide, let's say, if you will need a very quick pool, and you will not expect the caching working very nice, because let's say you have 100 terabytes of data, and all your 100 terabytes of data are warm data or hot data. In such case, that the pool need to be fast. So you will maybe create a pool consist of SSD disks only. In such case, of course, saving space is critical. Compression is working always. There is no performance degradation, and opposite, you can expect in some case in good compression performance improvement. And for the duplicated data, of course, you can use data deduplication. And then if the data is really duplicated, you may have a situation that from the VMware side, you see maybe 16 terabytes of data you already written. And from the storage appliance, you will see maybe 4 or 5 terabytes. This happens with our customers. Yeah? That's why I'm repeating. And accessibility, today we have iSCSI and NFS. Next in roadmap is SMB. And of course, everything is accessible. Doesn't matter whether it's already HA cluster or single node via virtual IP. So here we are cluster ready, starting with single node. We can configure virtual IP and access all the storage clients via virtual IP. When you will be connecting second node later on, then will be you will not need to change on the client side. Everything will be already working as before with single node. And the virtualization, all this pool storage idea, thick and thin and over provisioning is supported. So the internet storage providers can sell a lot of storage, but everything over provisioned. So you can have a few thousand customers, everyone has 100 gigabytes, but your storage is just few terabytes. And you will see physically data are written, then you will be expanding storage, adding data groups or just disks to the pool, and growing the physical capacity of the pool. Now, how it is connected? So in the hardware we have just very simple two the controllers, storage controllers, and just a JBOD. But because we talk about hyper-converged, imagine that we are not installing the JovianDSS operating system on your server or your controller, but first we are installing VMware ESXi, and Jovian is working as a virtual machine, so that will be a virtual storage appliance. Okay, next, same situation but more JBODs. So in this case we have two JBODs. We have option also to mirror disk over two JBODs, right? And the same as before, now instead of installing JovianDSS as operating system on the controller, I can install first the VMware and the JovianDSS as a virtual machine, as a VSA. Of course, you need to have extra settings with such a machine, like pass-through and setting this machine working with pass-through HBA. We are going to show this today. So this is set up where it's not hyper-converged, just a regular situation when you have a virtualization on the separate server and Jovian on the separate server. That's one option when we have two JBots connected with the SAS HBA, and we have 4 ports. First 2 ports are running a bond which is exported via one virtual IP, and the second 2 are forming a so-called ring to monitor both storage nodes each other, and also ping nodes will be there configured. So, and the ping nodes need to be external of the cluster. So in our case we'll be pinging our storage clients, so in this case ESXi or Hyper-V or Xen virtualization clients. Optionally we can also ping switches. Next slide. Now instead of bond, now we have a 2 path, means we make multipath, and then we are exporting via 2 virtual IPs, and we make multipath over these 2 virtual IPs on our storage clients. Next slide. A similar situation like on the very first slide, but here we have a just single JBot, right? And the rest is the same. And this slide is the most interested for us today, because here, as you see, we have the virtualization and storage cluster all in one. So our storage controller on left side first will run VMware, and the next it will run JovianDSS as a virtual storage appliance. So that will be virtual machine running under VMware. And of course we will need at least 2 VMware nodes. We can have a cluster with 3 or 4 or 5 or more VMware nodes, and just 2 of them will be running the storage, which will be high available storage, so iSCSI or NFS or both, for our virtualization cluster, right? So here I show here single JBot, but of course it will be identically or very similar working with the dual JBot. And here we have the virtual storage adapters on the left and right side. There are no more physical adapters because these virtual storage adapters are available from the VMware, and we will show how to configure our virtual IP addresses and how to set up that everything looks like here. So I will be switching to our remote server, where I have already everything installed, and then we will be going to show with step by step, maybe removing this installation and then coming back. So I will check if everyone is okay, if there are some questions. So far no questions. If you will have the questions, just please type them in the chat. Okay, so now I am showing you HA cluster configured, and I have 2 nodes configured in my cluster. That's just regular HA cluster, no fault tolerant configured yet. And I have here 2 Jovian machines running in my cluster, and I have already a test machine, a virtual machine, which is that's the user virtual machine, just single, but in our case it's enough to demonstrate everything. So I need to introduce first these 6 nodes. So when I go to configuration, and then when we go to the advanced settings, you will see that there is a controller listed already here as a so-called pass-through device. So this direct path device, when you will edit this, you will see all the devices which are PCI Express devices which are in the server. So very first, after installing your VMware, we will need to go here and we'll need to select our HBA to be a pass-through device. Means VMware will be not touching this device. It will be just passing through as available device to the virtual machine. Okay, on both nodes we made this. So on both nodes, when I go to configuration, advanced settings, we have this HBA, so host bus adapters, which is providing us the connection to external JBOD. They are giving us this adapter as available for the JovianDSS. And how we made it, how we connected this in JovianDSS. So when I was installing the JovianDSS, I have to, of course, go through the setup which was shown already in our last webinar. But when I go to our machine and then click on help, then in help and in release notes, always click on some release notes, there is explanation how the virtual machine need to be installed. So that's the VMware, and the most important stuff is this last line. Means you need to add a row disk.enable UUID and is equal to true in the options general configuration settings, right? And next very important is when I go to edit, then you see that we were adding a PCI device to this virtual machine. So next to adding all these virtual adapters and next to adding para-virtual SCSI controller and some CPU, some memory, here I have 32 gigabyte memory. Very new, and this is very important for the hyper-convergence, is that we are adding this HBA, which is now configured as a pass-through device. We are adding this to the JovianDSS machine. On node A and on node B or node 40, it's the same. We can see that we have this device. So we were just adding. When I was configuring, the PCI device was on the list here, right? But now it's not because it's already added. Okay, so adding this PCI device and selecting this HBA, now this machine is not able to move. You cannot vMotion such a machine, but this is great. We don't want that this machine will be moving between hosts. Okay, so this machine is somehow fixed to the host .30 and this machine is fixed to .040, right? And having this HBA pass through, the JovianDSS works actually almost the same as VMware will be not existing here, and the Jovian is managing this HBA almost directly. Okay, so now our user virtual machine, which is running here. One word for the JovianDSS. At this time I have tools which are out of date. We will just next day update the tools, and the tools will be available as up to date. So I have here Windows virtual machine. I have console already, so I can go to console and I'm running a test. So when I will 32 outstanding IOPS, and the random mix 8K. So when we will edit this, you see we have a actually 4K. I was changing this by meantime. So there is 4K, 100% random, and the mix. So we have a 33% write, 67% reading. So this kind of pattern, I will maybe save it. This kind of pattern, when we just start, okay, every second, last update, so we see what is the performance at this moment right now. Okay, so that's mixed performance on one target only. The performance is scaling when we are adding more targets, and look, this is a mixed read and write performance, 100% random. So very good performance. And this is performance on the virtual machine. We are testing here the local drive C of this virtual machine, right? Good. So now we will try a failover. So I will go to JovianDSS. So first JovianDSS, the IP of this JovianDSS is 32, and the IP of this second JovianDSS is 42. So 30 and 40 are my ESXi hosts. 31 and 41 is IPMI access to my servers, so I can maybe even reset, simulate hardware reset. And 32 and 42 are my Jovians. Okay, so as you see, on the 32 we have a pool 0, and the pool 0 we have just one iSCSI target, and on second node we have a pool 1, and we have also one iSCSI target. Both, they have, you know, just 9.77, so it's formatted, but it's 10,000 gigabytes, so something about 10 terabyte on the both sides. Okay, the both sides disks are connected to our ESXi hosts in the storage as a HA-SCSI 0 and HA-SCSI 1. They are both connected via Multipath. So when I go to the properties, manage path, so we see I have this 21 and 31 with round robin, and on the second one I will have 22 and 32 with round robin, right? So both data stores are available to the cluster, to the ESXi cluster. When I go to this node, of course, I have the same situation, only the local data store is 40, and here I have another local data store, but these are high available iSCSI targets. Of course, we can make also high available NFS data stores, right? So we have this available. My test machine now is connected to HA iSCSI 0, so that's the pool 0. How the storage adapter looks like. So the storage adapter in properties, we can see here there is nothing, no dynamic static configuration. So the static configuration, the target 0, which is on the node A, has a 2131, and the target 1, which is on the pool 1 on the node B active now, it's 2232, right? Same situation on another side. So here I have my both logical units. Okay, you see both has a 9.77 capacity. I can also edit here, manage path, and I see the same 2232, and here we see 2131. Okay, so we have 2 devices and 4 paths because of the multipath. Okay, so now it's time to show our user virtual machine, and now we are active on ESXi 0, so on the first machine. So when I go to the DSS, so to the JovianDSS, the pool 0, which we have here, I can make it smaller, okay, and just click on options and click on move. In this case, the pool will be moving from node A to node B. So now the pool was exported on node A and will be importing on node B. Maybe I will show shortly. Here we still have pool 1 only. Pool 0 is already there. So now after failover, you see it was slowing down to the native pool performance, and after a few seconds, because my testing file is not big, it is the cache is learning and we are reaching higher performance. Let us repeat this. So now both pools are active on the node 42, on the node B in our case, I can call it. So let us move this pool 0 back. Okay, let us observe what's going on when we are, before we are moving the pool back to our node A, or node 32. So after clicking failover, it is taking few seconds to start export, and after export is done, we see the performance drop down to 0 because we are checking every second. And after failover is completed, so the pool will be imported back on our 32 node, the IO meter on the virtual machine in this infrastructure will start to work. And so you see it was starting with quite low performance, and of course the cache is learning, so now everything put in the RAM cache, and we are reaching our regular performance. So this is how it works. We don't have a lot of time. We could maybe make some more exercises and maybe migrating this machine to another host or to another data store, but this is quite boring, takes some time. Machine is 40 giga, so we are not going to show it as it is not so very really interesting. I was testing this before starting the webinar. It was working great, but just takes few minutes to let's say vMotion between storage controllers, right? So between these pools I could migrate to ESXi 1 from ESXi 0, right? Let us see if there is any questions coming. So no questions so far. Great. We are able now to make some step-by-steps showing how to configure the cluster. I've forgotten maybe to tell you one word which is extremely important in case of configuring the JovianDSS as a virtual machine. You see the ping nodes are no more on the VMware hosts, but ping nodes in this case are configured on the switches. Ping nodes must be somewhere external of the JovianDSS. So unfortunately, when I will configure the ping nodes to the VM kernel which is running on this machine, it could be that ping nodes will be available in case of, let's say, losing connection between both servers. I can show you when I will, let's say we are going to simulate some network problem. So that's my management network, and let's say I will remove both cables, then I will lose management connection between two ESXi, and also my ring from my storage cluster works here as well. So in this case both storage cluster cannot see each other, but both storage cluster, if the ping node is configured wrong, can ping locally, and in this case we'll have a split brain. So before starting production, you will probably run a virtual machine which is writing and let's say removing this connection between two storage cluster physically, and you see whether machine is working, whether failover is working properly, right? This will be always working properly if your ping nodes are configured properly. If you will see that you make an error, you will need to correct the configuration. So in order to show how to configure step by step, this is quite a lot of work, so I will do it only on one machine, and while I will make sure that you will be able to repeat the same process on the second machine. So because my virtual machine is running on the first pool, I could have a problem and I could maybe reconfigure the second pool. The first pool is up and running. The second Jovian is not really important now, so I could even shut down this machine. So I can, let's say, go to my second machine and I can click here and shut down, right? Of course, I could also shut down the machine using my tools here. Now it's not showing shutdown because this is just shutting down, but I will go to the you see that I can use the shutdown guest with Ctrl D or just using this menu. So the second Jovian is shutting down just from the GUI. So I will be able to, let's say, delete this Jovian and recreate this Jovian one more time, new from scratch. Also, the second node has storage adapters, and these storage adapters are configured for to access the storage, right? So we could remove it as well. Let us see whether the second is shutting down. Okay, I can see the progress also directly going to the console directly. So that's my console of the Jovian. Somehow it is not showing yet. Let us see what's going on here. We have kind of problem. The VMware does not show. Oh, it's not showing because by meantime it was not refreshed. This machine is already powered off. That was the reason. Okay, so this machine, when I will try, of course it's shutting down. So I don't have this machine, but so the pool 1 was moved, activity of pool 1 was moved to the first because this is a cluster, so I was shutting down this machine, right? How is the virtual IP configuration? When you go to virtual IP, you will see that there are two virtual IPs. Of course, we have a local and a remote machine virtual IP configured. The virtual machine, the second machine is not available right now, but the configuration is still persistent, right? And that's the 2131, that's the first pool 0, and the 2232 accordingly for the 22 and 32 for the pool 1, for this our second pool, right? Okay, so we have stopped this machine. So this machine is no more running, and what we can do to show the step by step, we can just remove this disk. You can delete from disk. So this machine is configured on the second. So when I will just delete from the disk, this machine totally disappears. So now I go to the second pool, to the second ESXi, and also I will remove the storage adapter configuration. So in properties, I will just remove. Because both nodes are in cluster, so removing this, it's taking some time. Maybe it was a good idea if I will also remove the cluster. Takes some time. The vCenter will need to update everything. Especially doing things which are not really regular, like removing this, takes some longer time under ESXi. Okay, I'm done. When we rescan, all the storage will of course disappear on our host. When the rescan is done, of course everything will disappear here because we have no more configuration. And the two ports configured for the VM network, this is quite obvious. You will need to always do it. And that's my virtual switches, which has a iSCSI 3132 and 2122. And what we have here also, we have a virtual machine port group, because our Jovian must have access to these switches. So when I will, let's say, remove these two switches, okay, I have only a VM management switch. Okay, so I don't have here, so this is like fresh installed. The only thing is just the two adapters. So what I will need to do as a first step, maybe I install the Jovian machine here. So on my system I will just add and install typical or custom, doesn't matter, Jovian machine, and I would like to say JovianDSS.40. That will be 40 means machine installed on the second host. The machine will be placed on the local data store here on the second host, because when we boot the host, we want to boot the storage machine, so this needs to be boot from the local disk. Okay, and that will be Linux, that will be 64-bit Debian, that will be, let's say, 4 cores, that will be, let's say, in our case 32 GB RAM for the Jovian, and we need 4 ports. All the ports need to be virtual driver. That's the best way, because in this case when it's 10 gig will be passed through 10 gig. And this LSI SAS or paravirtual. Paravirtual is probably the best. Okay, we create a new disk. So for the boot disk, 16 giga is enough, but I am creating always somehow 20 giga disk to boot Jovian. Okay, and that's it. The machine is created, but now we need to install. So we will need to install the machine. So we will add just ISO image. So that's the Jovian, that's latest Jovian ISO image. So we'll add ISO into the CD, virtual CD. And now when this is added, we can already install Jovian. Okay, so I just confirm this. Launch software installer. So the software installer will take the data, the ISO image from the ISO file, and will show us which disk is a destination disk. So today now it's just this 20 giga disk, and we will confirm, so all this data will be moved to this 20 giga disk and make this disk bootable, and that's it. And we are ready to start the Jovian. Okay, so now we have just a license prompt, which I just confirm. The only one disk is now available, so we just confirm. And we will be installing Jovian on this disk. Okay, data consistency check, and just reboot, and just confirm to reboot. Okay, and after rebooting, okay, it's already, now it's launch system, so no more installer, means that it was installed properly. It is probably also a good idea to remove the CD, so ISO file, or just change to the client. So this will be no more connected to this ISO file. There will be no problem. Actually, there will be no motion, but better is to disconnect this. So that's the machine. This machine is booting now, and we need to add the PCI. Okay, but as machine is on, we have no option to change these settings. Okay, so now that's the machine 30. We need to access machine 40. Okay, of course the network IP addresses are wrong. So now with Control Alt N we can edit the IP addresses, right? So the IP addresses will be just 042, so there will be 032 on the first machine. Okay, here we can also add the gateway 192.168.0.1. So I'm changing the network settings, of course. Otherwise, there are sometimes, conflicting IP addresses. I have to do it. Good. The IP addresses are connected. I can even select this one for the default gateway already. I can do it, of course, in GUI, but I can even select also DNS. Let's say put Google DNS, public DNS. Oh, wrong DNS. 8. Good, so we have configured a network, but as I mentioned already, we will need to configure some more. So Control K is giving us option to shut down this machine, and we still need to change this disk enable UUID because a virtual machine under VMware is not exporting the disks by ID. Okay, so now I go to the options, general, configuration parameters, and I need to add a row disk dot enable UUID is true. Okay, so this was in the, I have mentioned this was in the help in the resource in the release notes. Next one, we need to add this PCI device. Okay, so we add PCI device, which is here, and then we go to next. And this device is already available here because we were setting pass-through. So remember, just after installing ESXi, you will need to select the HBA as a pass-through device, of course. And now we can add this HBA as a kind of, private device for this virtual machine. Okay. So now we have it. Let us look like how it looks like, and this PCI device show here as a pass-through device. There is no that will be problem with the moving this machine, but we want to stick this machine to be always stick to this host. Okay, so that's it, and now we can boot this machine already. So this Jovian will be just fresh installed. So this Jovian will have no, cluster settings. Okay. So now, while it is booting, we will reconfigure what is missing on this 6 host. So we add networking first. So we add VM kernel. And this VM kernel, I will use the first 10 giga card available because I want this for iSCSI export. this iSCSI export between ESX hosts, of course, right? So here I will just say the first one is iSCSI maybe 21, right? 21 and 22 on the first port I will need to add. So the 192.168.21 and my host here is 40, okay? So I put 40. Okay, so we have we don't need gateway. So we have a 21. So now when I go to properties and add, we need to add one more VM kernel, and that will be iSCSI 22 for the second pool, right? Okay, so 192.168.22 and my host is 40, so I put 40 here. Good. So now we have the both access to both resource pools via the first path. That's why always 20 and 21, 22. So 21 will be access to pool 0, target 0, and 22 will be access to pool 1, target 1. Okay. So now we add one more networking, the second multipath path. So in this case I have second 10 giga card available. So now iSCSI 31 first and then 32, right? So 192.168.31.40 of course. No need for gateway. And one more VM kernel, iSCSI now will be 32. (31, 32), right? And the host is 40. Super. Okay, so now we have the management port, which has a dual card 1 giga connected. Then we have a one virtual switch using a first 10 giga card with 2122, and the second part is always 30, 31, 32. Super. But we will need to connect the Jovian, this Jovian will need to connect also. You see, I have only VM network available because I'm connected to management port only. So here, when I go to edit, you see, here I'm connected to VM network. Here I'm connected to VM network 20, 30, and again VM network, right? Important is this MAC address. Okay, so we need on this host, we need also here same config as on the first one. So you see, I was putting VM network 20 and VM network 30, right? So let us do the same. So here will be VM network 20. So I will just add it as a virtual machine in order to connect virtual machine. So VM network 20. Maybe some distinguish that is on the host 40. You can add such a stuff also. So 20. Okay, and VM network 30. So now we go to properties, add not the VM kernel but virtual machine. So VM network 30, and let's say on host 40, just maybe to avoid any conflict names, if any. Okay, so I have now two another VM networks. So now I need to connect two cards from this Jovian to these two switches. So I need to edit this machine, and yeah, here I have a Mac 05, here 5C, here is 40, here is A0 on the end, of course, right? So this will be important information because I have 4 ports when I go to my Jovian. I will need to create a bond. Of course, because I'm new installing, I need a license. So I have the keys here. Okay, so something wrong with the copy paste. Copy. Okay. And the cluster. Okay, cluster key. We can run admin because the machine is installed new from scratch, so this is asking also for license. Okay, so now we go to system settings and network. Okay, so we will need to make on these two cards, they are all identical, all 10,000, because the para virtual driver is always passing like this here, because I have 10 giga cards there. So now I create a bond for the ring. So on my first machine we have created also the bond for the ring, and the bond for the ring, you see I was using ETH0, and ETH1 is my bond for the ring, right? So here there is a not very nice name, so maybe I can go to the network and put the proper name. So the server name will be, let's say, node 42, right? Host name maybe also node 42. Okay, now you see you have a nice name over there, and let us create a bond like 042 IP. So these two cards I'm selecting for bond. Now I'm selecting, it must be active backup for ring. Then we are selecting primary, it doesn't really matter, but I want 8080. We see that will be potential MAC address. Okay, static, and I will just enter the IP address of my first card, so 192.168.0.42. net mask and that's it. So yes, it will of course change my gateway, because the gateway was assigned already to the first card. Now I need to log in one more time because the network configuration was changed. By the way, this is trial version, needs activate, so when I go to activate now and then I activate and then I use online activation, it will not work now because my gateway is not configured yet because I was changing. So I will have an error, but when we fix it, okay, so in the network now you see we have a bond, and in this bond we need to go and change, so edit, we need to put the gateway 192.168.0.1 and apply. Okay. DNS was configured. Not yet. Okay, so now we need to select this gateway. So I go to change and select this bond as a default gateway. Now the DNS is okay. So now I should have access to the network. How to change it? Check it. Just go to system and make a continuous NTP synchronization, and if it works without error, means you are connected properly. So your DNS and gateway, standard gateway is working. Okay, good. So now we can activate. If there is no restriction on my IP, maybe it will not activate because this was blocked by myself. Okay, because I was using this key many times. So, but I have 5 days to work on the full performance. I say this serial number is blocked in our database because it's used for webinar only. Okay, so now I don't have the storage yet, but I see already the available disks which are not used by all the pools, right? Anyway, I will not create the pool. I would like to join the cluster and move this pool from another node. So, but let us complete the network settings. So I have a bond and I have 2 cards. So you see I can go here and in edit I see that this card is 5C. So maybe I want 5C for the network 20 and that card is 40. So for the next network. So 5C, I will be going here to the edit settings and find the 5C. Okay, that's not 5C. This one is 5C, so I want 20 for this one. And this one is 40, so I want the network 30 because I have 20 and 30. Okay, so for this ending 40 I have second network, and for this ending 5C I have first network. It means the rest are connected to this bond, the rest are bonded, so that's why I'm selecting proper cards. Okay, so now this machine is quite good configured, and when I go to the machine settings, to the failover, probably I will be able to make the bonding. So maybe I go to the first and see what's going on. The bonding is here somehow showing a connection, but I need disconnect, right? So disconnect, and reconnect. So with reconnect I will reconnect my cluster. Notice that everything is done while the Windows machine is working. Okay, so we didn't stop our production at all. After disconnecting, I will be connecting the cluster, configuring cluster new. Okay, now it was refreshing the GUI, so now I can go and connect my cluster. So 192.168.0.42 admin is my current password. Always need current password. Is later password change, doesn't matter. So okay, we are connecting, and when everything was properly configured, I will be able to configure the ping nodes, and I will be able to start the cluster. But remember, the ping nodes in our case are something what is not, because this is a virtual infrastructure, it is not the ESXi clients. It need to be something else, maybe switches. I was showing on the chart. I have already 2 external IP, persistent, working all the time, 192.168.0.20. That's my first external, maybe switch. This is not switch in this case, but let us assume it is switch, and 192.168.0.100. You need, with one ping node you can start the cluster, but you will have a warning that you need at least 2. We recommend minimum 2, 3 or 4 ping nodes. Okay, the ping nodes are reachable. You just maybe enable this SCSI persistent 3 reservation. Okay, if it's not, ring is already configured. The ring is our bonds connection between both. In this case, this bond is a bit artificial, so you must have also bond on the configuration here. These 2 cards, because we need a redundant connection, and we made a bond, but we didn't make any pass-through of these devices. But we must make a bond on the Jovian, because by design it will not start the cluster if it's not the bond. But in this case, it's not the real bond, because don't have the real 2 physical IP, physical cards assigned. They are virtual cards. Okay, so it could be that we have 1 card only here, and everything will be working properly, because this 1 card is kind of made 2 virtual cards of them. So it is important that we have these 2 cards always here. So now cluster is ready to start. Maybe I will restart my GUI. Okay, so cluster is ready to start. Let us try to start. Yeah, it takes about 2 minutes to start the cluster. So by meantime, we can check whether all the settings are there. So we can already try with storage adapters here. So on the second host, the storage adapter is not configured yet, so I will just add. Okay, I can add because the pool was already there. I need to create a new pool on the second node, because the pool was moved, but creating a pool is not a big deal. Now I need to add the for the target 0 and for the target 1, so maybe I will copy from the pool how is the target name. So in the 0, the target name I can access here. Okay, click on edit, and I can copy the target name like this, and then I can go to my storage adapter and configure. So 192.168.21, yeah, the IP, I need to enter now the IP of my iSCSI target. So I need to know what is the virtual IP of my pool 0. As I know, it's I was giving always 100 on the, yes, it's 100 on the end always. Okay, so we can go and say 100. That's the target 0. Then we 192.168 second path, so 31, 100 and the target 0. And now we are connecting to target 1, so 192.168 22 100 and the target 1, and the second path 192.168 32 and the target 1. Okay, so we see everything looks nice. 21 31 for target 0, 22 32 for target 1. We can just see that the devices are already appearing. Maybe we just, okay, so everything was configured properly. Let us see whether the cluster is already working. So cluster is started and we see all pool 0, pool 1. Of course, everything is active on our node 32, so on the first node. On the second node, we see cluster also started. Everything is, the resources are not found. Maybe we just need to refresh the GUI. Aha, the resources are okay, active on A, but they need to be listed. Yeah, they are listed already. Everything is started. Okay. So it was configuration which was successful, right? So now I just check whether the host properly see the storage. Yes, that's the case. So now the both cluster storage data stores are available on my second. So we are successful. We made it. So the virtual machine is still running here, and now I can go and then send the pool 0 actually to home. So I was operating, the machine was operating on the pool 0, but this is not a big deal. That will be everything the same if it will be on the pool 1, because now when we'll be moving pool 1 to the another node, we can just next move pool 0 to another node. So now we balance, so the pool 0 is staying on node 32 and the pool 1 is just importing on the second node, so the 42. So now we have a balanced cluster. After balancing the cluster, both storage controllers will be working and giving us all this RAM, cache, and so on. So the hardware will be fully utilized, right? So now we are kind of situation which we want to run the production normally. And the pool 0, of course, now because let's say for testing we can move or reboot the host or reboot the node and see how it is working. Again, while moving, the performance should drop to 0, and then after 10-15 seconds, when the pool is already imported on the second node, the performance will start with a bit slow, because native pool performance without caching, and then few seconds later, depends on the test file, of course, if the if data is very big, then learning process is of course not just few seconds but even hour or longer. Okay, so just few seconds more and the pool will be important on the second node. Pool is imported already, but somehow there is a problem. We probably I made a really mistake because I was reconfiguring the network, so that's the real mistake. I supposed to reconfigure the virtual IP. So let us move this pool back. Okay, so yes, I didn't make this properly. The importing and exporting pool works proper, but the virtual IP need to be of course reconfigured, and I forgotten about it. So I need to go to edit and for the second add the the 2 okay, that's my, because I was editing the node and the node was removed, of course, so that's obvious. Okay, and the same thing here. Okay, so maybe when you are testing the cluster, everything, maybe make the move on the before moving, you prove that everything is configured properly. Okay. It was nothing on the pool 1, but on the pool 1 we have exactly same problem. Right, on the pool 1 I need to fix the same problem. Here is opposite, you know, this is missing. Okay, but that's obvious because it was physically, I was physically deleting this machine, so the machine was physically disappearing. Okay, next time I need to remember. Okay, so let us activate it. Yeah, when you will just physically remove this machine, of course the first is working, but of course these interfaces are disappearing, so cluster continue to work, virtual IP are still available, but of course failover will not happen because these interfaces are missing, right? So now our pools are properly configured and they are now really available for failovers. And here you see in the gray I have pool which is listed from the second node. If I will just refresh the GUI, this will disappear. If I will want to see them again, I will need to rescan. Okay, so now we have a situation when we have balanced cluster again, and I'm starting the iometer new. Okay, so this is already working. Maybe I will just put nice 30. Okay, so let us check when everything is available here. Rescan all. Rescan in progress. Completed. Everything is available, and here the same story. We need to prove when everything is properly connected. And of course I had to prove whether my virtual IP are active and working. Yeah, it was active, so now we are on the proper side and we are ready to failover. So now we'll be moving. Okay, so now pool is totally exported and supposed to be imported on another side. And that's the case. So now it is learning the cache. And after learning the cache, I can already, let's say, pool 0, pool 1 is active on B. I can move it home. Okay. Good. So let us see, is there any questions? So no questions so far. Looks like everything is so easy, or everything is so difficult. Anyway, the record is done, so we will be placing the record on our website. You will be able to watch it one more time. Please make sure when you will be configuring the cluster, you will test the configuration before you start production. And you will test also removing the, let's say, 2 cables from the host, to simulate kind of a situation which is potentially for split brain. So I'm mentioning to you that you can go and remove these 2 cables from this host to have both hosts on management port not connected, to see whether your ping nodes are properly configured, right? So the ping nodes must be configured like here, that these ping nodes are not in these machines, right? So in this case, when this is done and you have disconnected the cables, the pool which was active on B should be activated on A, right, properly. And after putting the cables back, the pool will be, which was active on B, after let's say 1 minute will be sent back to guarantee the load again automatically. Okay, so we are done for today. It was a bit long, but 1.5 hours is still okay. I would like to say thank you very much for joining us, and watch it one more time because it is recorded, will be in a few days on our website. And good luck with the configuring hyper-converged high availability infrastructure. Thank you very much, and bye.